Okay, welcome back to Hot Topics. Some of you may have watched our previous video on factoring trinomials. In this little video, what we're going to do is just summarize all of factoring for you, because now that some of you've had elementary algebra, some of you are now first time in factoring with intermediate, we like to summarize everything for your brain. So when you walk into a test, you walk into anything, you look at a problem, you have some mental steps to go through, and we basically cover every type of problem in this short little video, hoping to help get everything organized up there in your attic. So anyway, we're going to go and get started. The first rule of factoring is to look for a common factor and take it out. Always. Because most students, if they can't factor something, they've skipped rule one. So these first two problems, or actually this first problem right here, you look at that and you say, wait, there is something common in both of these terms. You should notice that there's a 5 that's divisible into both of those and an x. So what do you want to do? You want to take that out. So taking that out means you just put it on the outside, and then you ask yourself, 5x times what is 5x squared? Well, that would be an x. And then 5x times what is 25x? That's 5. And that's it. There's no square on this. There's nothing else common between those terms. You are finished with that problem. So rule one, take out something that's common. The second rule, when you look at a problem and you go, well, there isn't anything common here, you then count how many terms are in the problem. This is a binomial. We have 3 different situations to look at for binomials. This is the one that carries over from elementary algebra. You notice the difference, and then hopefully these two numbers stand out, the 36 and the 49. Those are what we call perfect squares. So to factor this, this is a difference of 2 squares. If you do not recognize this, you will never guess it from what we've learned. You've either got to see it and know that this is going to be 2 binomial factors, or you skip it, and we don't want you skipping anything. So the square root of 36 is 6, and the x comes with it. The square root of x squared is x, so you put your 6x in the first position in both parentheses. And then your 49, the square root of 49 is 7. And notice, you don't have that middle x term. The way you get rid of that is you put a plus and a minus, or revert the order, put a minus and a plus. The key is the signs have to be different, because if you want to do a quick little mental check here, that is positive 42x. That is negative 42x. So that means you don't have an x term. So,
and if you would just draw some eyebrows there, you would have a nice little face.
yeah, my middle school teacher called that George.
They call that George? Is that
so
true?
that is the final answer to that one. So again, look for something common. Then after that, count the number of terms. These next two are also binomials, both of these terms. And since we haven't discussed these before, we decided to do 2 examples. But these numbers should stand out on these problems. These are not perfect squares like the previous problem. These are what we call perfect cubes. Now, later on in this course, we're going to do a hot topic on radicals and perfect cubes, but let me go ahead and write out some perfect cubes here. 1 is a perfect cube, 8 is a perfect cube, 27, 64, thank you.
Sure.
125, and typically we don't go beyond that. But when you see these numbers, obviously a couple of these numbers, the 1 and the 64, are also perfect squares. So that's when you look at the power on the x to go, it's a perfect cube I'm looking for, not a perfect square.
Right. If you see a problem involving the third power and it's a binomial, it's got to be either a sum or a difference of cubes. It's not going to be a perfect square problem. And just to be clear, when we talk about a perfect cube, we just mean it's a number you multiply by itself 3 times. 1 is 1 times 1 times 1. 8 is 2 times 2 times 2. 27 is 3 times 3 times 3, etc.
Yeah, so you don't have to memorize these. When you get a test, I always tell students, write out your perfect squares, write out your cubes, because then when you get to those problems, they're just there. They're a reference. So now let's go ahead and look at this problem. There is a formula. This is not something you're supposed to just come up with in your head. The formula, and I'll use A's and B's, is A minus B, and then A squared plus AB plus B squared.
Do you want to write the equals A cubed?
Okay, this is A cubed minus B cubed
Jerry's
equals this right.
Me. Right, Jerry's humoring me.
So the first step in these problems is to find A and B. So A is the cube root of this first term. Well, the cube root of x cubed is x.
Because x times x times x is x cubed.
That's it. And b in this problem is the cube root of 27, which is 3. Now notice I did not take the sign. The sign is accounted for in the formula.
Right. There's one formula for problems that are a cubed minus b cubed, and as Jerry will show you in the second example, there's also a formula for a cubed plus b cubed. So you don't have to worry about the sign when you figure out a and b.
Now we're going to go straight to the final answer. Substituting in our x and our 3 for a and b, you get x minus 3. And now when you substitute your x in here, you have to square it, so that's x squared, plus 3 times x is 3x, plus, now remember 3 is squared in the last position, so it's 9.
Now, you may be tempted to now try to factor x squared plus 3x plus 9 because that's a trinomial, but in these problems, that second trinomial can never be factored. It's not factorable. So when you're doing a sum or difference of cubes, once you get to here, stop. You can't do anything else.
Okay, and this is our final answer. Now on a test, if you have time, you can always go back, distribute out the x minus 3 times all the terms and verify, but for now, we will leave that up to you.
We promise you it's right.
All right, this next problem, you notice the sum. That's the only difference between the two. It's still it contains all cubes. So the formula for a sum of two cubes is the following. A plus b, and then a squared minus ab plus b squared. Now you do have to memorize these formulas for a test. They are not given to you, and it might take a little practice, but you should be able to see some very common terms here.
There's also a shortcut for remembering the signs, which I'll talk about, I guess, now.
Go ahead.
This is something I want to give credit where credit is due. When I used to work in Georgia, somebody I work with taught this to me, and I think it's great. The magic word is SOAP. SOAP stands for same sign as the original problem, opposite sign as the original problem, always positive. So that first sign, a plus b, matches the plus sign in the problem. The second sign, minus AB, is the opposite sign from the problem. And the last sign, you can compare the two formulas as always plus. This is probably the easiest way I know to remember the signs, which is the only reason I bring it up.
Okay, so now with this problem, all we have to do is identify our A and our B. Our A is the cube root of this whole term, so that's going to be 2x in this one. And B is going to be 5, because the cube root of 125 is 5. So now substituting these in to our formula, you get 2x plus 5. And this is where, if you're going to make a mistake, it's going to happen here. Make sure you square A. So that whole term squared is 4x squared. Then minus 5 times 2x is 10x. And then plus 5 squared, which is 25. And that is your final answer.
Again, you cannot factor 4x squared minus 10x plus 25. You can try it. It won't factor. Don't bother trying to factor these. It's just a waste of time.
That's it. So here's what we've done so far. Step 1, you look at a problem, look for something common, take it out. Step 2, count the number of terms, and then use one of these procedures that we're showing you. So far, we've dealt with binomials.
Right. So if there are two terms, it's either a difference of two squares, a sum of cubes, or a difference of cubes. Those are the only possibilities.
That's it. Now we're going to go to the trinomials. Now, just to review, in case you didn't watch the other video, trinomials, you basically have two types. One with a power or a coefficient on the x squared, one without, pardon me, and then one with. The one without is, of course, the easiest one to deal with. Write out all the factors of 12 first. And then you ask yourself, what factors of 12 subtract to give me that middle term, 1? Well, obviously it's the 3 and the 4. So you put your two sets of parentheses down here. Your x always goes in the first position. 3 and the 4 can be in any order. And then you say, all right, I want a negative 1 when I subtract these two. So the 4 is going to have to be the negative value. 3 is going to have to be the positive value. And that's it. That one's factored. The second one, again, Bill had a great discussion on this in the previous video. When you see those coefficients at both ends, this is where you start out and you say, all right, I've actually got to look at the factors in this problem of 42. Not the factors of 6, but the factors of 42. So all the factors of 42, 1 and 42, 2 and 21, 3 and 14, 4 doesn't work, 5, 6, and 7. All right, you want the factors of 42, just like in the last problem, that subtract to give you 11. Well, that would be the 3 and the 4 right here. So you rewrite the first term, 7x squared, rewrite the last term, the minus 6, and now we're going to substitute the 3 and the 14 to create 11. So to create an 11 by subtraction, we want the 14 to be positive and the 3 to be negative.
And remember, the x just gets carried along for the ride.
That's it. So basically, these two problems are the same at this point. It's just we've expanded it a little bit. And then from here, you're going to use that grouping method, which we're going to discuss in the last problem. All right. Out of the first two, I can take out 7x. And that leaves me with x plus 2. Out of the next two, you always want to take a negative if that third term's negative. So we're going to take out a negative 3. And again, x plus 2.
And again, as Jerry said in the previous Hot Topic, but in case you didn't watch it, if you don't get the same thing in the two sets of parentheses, notice we have an x plus 2 in both places. If that doesn't happen, go back. You must have made a mistake somewhere. These problems are rigged so that they'll work that way. If they don't work that way, something's wrong.
Yep. So your final answer, you pull out the x plus 2, and the 7x minus 3 goes in its own parenthesis. And that is your final answer. So those are the two types of trinomials.
Jerry, you have a typo I just want to fix. You wrote 7x plus 3, but I know you mean 7x minus 3.
Thank you, Bill, for catching that.
Okay.
Actually, we planned that, because that's why we always tell you to go back and check your work.
That's right.
All right. Now again, so far, what have we done? We look for common factors, we take them out. Then we count our number of terms, binomials, difference of squares, do I have cubes? Is it a trinomial? If so, is there a coefficient on that x squared, or is there not? Now the last one is when you have 4 terms. And the 4 terms, simply put, you just saw what we did, we're going to group. So you immediately jump to here, because again, there isn't anything common in all 4. That's the key. Students see those x's and they want to take them out, and I said, no, you can't do it, because there's not one in every one. So out of the first 2, I can take out x squared. Out of the last 2, I can take out a 2. And again, these x minus 5s have to be the same when they are. You take them out, and then the x squared plus 2 goes in the other parenthesis. And that is the final answer. Again, if you want to check anything that you factored, go backwards and multiply it back out.
Remember, if you multiply it out, you should get what you started with originally. So it's always easy to check a problem involving factoring. If you multiply it out and you get what you started with, you must be right.
All right, now this last one's kind of a summary of everything, because there is a 4th rule, or should I say a 3rd. Rule 1, look for common factors. Rule 2, count the number of terms and then factor appropriately. Rule 3 is to double check. Can it be factored again? Every now and then that happens. So if we go through our mental approach here, this one, step 1, I do see something I can take out. I can take out a 7. That leaves me with x squared minus 4. Now again, prior to this, you haven't seen one of these, but now, hey, I can factor this again, can't I, Bill?
That's right, because this is another difference of squares. So don't just factor out the 7 and think, oh great, I'm done, I can go to the next problem. You have to look at the x squared minus 4, and before you go to the next problem, ask yourself, can I do any more factoring? And this one is a difference of squares, and so we can factor it further.
That's it. Carry the 7 down, because remember, you always have to carry down what you factored. The x squared minus 4 is a difference of 2 squares, so the square root of x squared is x. Square root of 4 is 2. Remember, put your plus and your minus in there, and then that completes it. Now it cannot be factored
Right,
anymore.
because if you look at those 3 pieces, none of those pieces can be factored any further, so that's as far as you can go.
So this kind of summarizes the process involved in the brain. We didn't dwell a lot on each individual type of factoring. We wanted to get you to that point where you just look at a problem and your brain goes through those steps. If you do that, you'll be fine. You'll get through the end of this course without a problem.
And where's more on this in the book?
They're going to find all this in Chapter 4 in the textbook. You'll see several sections on factoring, and just take your time. Our examples are written the same way we just did them here to really clarify things and to help you out.
All right, take care. We'll see you in the next hot topic.